Right, so this one here, I'm going to do some standard form, and I've been asked to do this question here, which says, evaluate and write the answer in standard form, rounding the answer to 3SF. So standard form, and we want three significant figures. So the first one is A, and A says, I'll just make sure I can see what I'm writing here, is 4,000 times 3,300. Now you can use a calculator, of course, to do this, and it's probably quite wise to actually do exactly that. So let's have a go at writing this in standard form. So we could just multiply it out manually, but since we can use a calculator, I'm going to do that. So we got 4,000, 4,000, and we can multiply it by 3,300. And we get 13,200,000. All right, so here we go. So that equals 13,200,000. All right, it has to be standard form, has to be three significant figures. So this is what we're looking at, and we want to make one. We want to have a single digit and then a decimal place. So how do we get the decimal place? Because at the moment, the decimal place is always to the right of the number. So it's going to move 1, 2, 3, 4, 5, 6, 7 places to arrive there. So it's going to equal 1.32. That's my 1, 2, 3 significant figures times 10 to the power of 7. And there's my solution. So that's all we had to do. All right, well, the next question is B, and B says, write, and I'll just write this down now so I've done it. Let's have a look here so I can see what I'm doing here. All right, so here we go. Sorry, 1 second. Okay, so B is 3.2 times 10 to the power of 3 plus 56 times 10 to the 2. Well, this one really isn't in standard form. All right, so let's do that again. And again, we can use the calculator. Calculators are perfectly permitted. So although what I'm going to actually do is I'm going to do it differently. I'm actually going to write this out in full. So 3.2 times 10 to the 3. So 3.2. So I'm going to increase this by a magnitude of 3. So I'm going to go 1, 2, 3. That's where the decimal point lands. And we've got a 0 in here and a 0 in here. So this is 3,200 plus 56. Decimal place is there, and we've got 2. So 1, 2. Decimal place lands there. We've got 2 zeros. So I've got 3,200 times 5,600. Now you could just do this on your calculator using the standard form, the exponents and things if you wanted. But I'm not going to do that. I'm just going to just multiply it straight out on the calculator. 32 times 56, 32 times 56 with the zeros added in. And I get 17,920,000. So that's 17,920,000. So at the moment the decimal place is here. And we're going to go 1, 2, 3, 4, 5, 6, 7. Again, it's 7 decimal places. Sorry, 7 movements of the decimal place. So it's going to equal 1.792. I'm going to write the 2 in and put times 10 to the power 7. But that's not my final answer because, remember, we were doing this to 3 significant figures. So here are my 3 significant figures. 1, 2, 3. I look at that next figure and ask the question, is this a 5 or more? If it is, I bump the 9 up to a 10, and suddenly this becomes 8 and 0. But it's not, it's a 2. So I'm going to cut it off there. The 2 plays no part in making these figures or changing these figures. So it's going to equal 1.79 times 10 to the power of 7. And there is my answer. All right, the next one is fantastic. What we got here? Okay, we've got 1.078. Hang on, so here we go. In fact, I'll write this on a different sheet. Here we go. So we're going to have 1.078, and that's going to be times, let's make sure I get this right, 2.4 times 10 to the negative 3. 2.4 times 10 to the negative 3. All right, well, it's a negative 3, so the decimal place isn't moved to the right to make it bigger. It's moved to the left to make it smaller. So I'm going to rewrite this as 1.078 times, and I've got 2.4, but I'm going to move it 3 places down to the left. 1, 2, 3. Decimal point lands here, and I'm going to put a 0 and a 0 in the gaps, and I'm going to put a leading 0 at the front. I didn't really leave enough room there, did I? So really what we've got is 1.078 times 0.0024. So let's just do this on the calculator, just to make life really simple. Here it is, and it's going to be 1.078, 1.078 times, the other one was 0.0024. Was that right? Yes, it was. Okay, equals, and I've got 0.002587. 0.002587, and that is the answer. Now, of course, we need 3 significant figures. So the first thing is to turn it into standard form. So I want something point something, and I can see it's going to be in between the 2 and the 5. So we're going to move it 1, 2, 3 places to get to the decimal point in there. So it's going to be 2.5872 times 10 to the, well, this is a small number, it's not a big number. So we moved it 3, so it must be a minus 3. So this represents a very small number. The minus means we're moving the decimal place to the left to make it smaller when we turn it back into just a general form number. Now, but we still have to make it 3 significant figures. So here are my 3 significant figures. Now, we could just cut it off there, but we always look to the next figure and ask the question, is it 5 or more? Well, it is, it's 7 or more. So I'm going to I have to bump up the next figure by 1. So this is now 2.58 plus 1 makes 9. And the rest we ignore, and we'll simply say times 10 to the minus 3. And there is my solution. I'll put an equal here as well, but that's the answer which we're after. Okay, next one. What do we got? Oh, I like this one a lot. This next one here, and I'll just bump up the page a bit so we can see it. This is number D. Here we go. And it's 0.0002 divided by, and this is quite a big number now. It's divided really by 5.4 times 10 to the 4. And just to put that in perspective, what that actually looks like, that would be the same as saying 0.0002 over 4.5, I'll put a very small 5 point there, and it's going to move 1, 2, 3, 4. So we're really taking 0.0002 and dividing it by 45,000. So that's really going to make this into a much smaller number than it was before. Let's see if I can do it on the general calculator. I'm not sure if it'll work, because it's probably going to take up more decimal places than my calculator will do. But let's have a look. 0.0002. Oops, I don't like that ring light in the middle. And we're going to go divided by, and it was 45,000. Here we go. Divided by 45,000. Here it is. So, yeah, it's going, the numbers are going to go right off the screen here. But I can just use a general scientific calculator. And so where do I end up here? So let's have a look. So it's 0.0002 divided by 45,000. Oops, too many zeros there. Delete one of them. Here we go. Equals. And this actually gives us the answer straight out of the box. Now, I know you can use a calculator in the exam, but this gives you the answer straight away, which is 4.444. So I'm just going to write that equals 4.44. And it keeps on giving more 4s, times 10 to the minus 9. I'm assuming you can do that. Anyway, the next number would be another 4. So the question is, so there's a 4 sneaking in there, yeah? And the 4 is not 5 or more, so it plays no part. So the answer would be 4.44 times 10 to the minus 9. And because we're doing it to 3 significant figures, there's no need to show that it's recurring. We can just leave it like that, And of course, if there was units like these were kilograms or kilo something, you'd throw in the temperature or the distance or the mass or whatever it was and make the units plain at the end. But we don't have that in this situation, so that would be my solution.